now to the University of Pennsylvania School of Medicine in Philadelphia for a roundtable discussion on curing cancer with Vice President Joe Biden.
Well, Madam President, thank you very much, and thank all of you. I know, in a sense, this is taking you from all the important work you're doing, but Dr. Collins and I are here, and I've had an opportunity to speak with my friend, and she really is my friend, Dr. Gutman, President Gutman. And I, like so many of you and maybe members of the press and their families, I am a typical family in that my family's been touched by cancer. Some family members have survived, some have not. My mother, God love her, used to have an expression. She said, Joey, a little bit of knowledge is a dangerous thing. And when you are, engaged with someone you love who is fighting for their life, you become acquainted with at least the parameters of what they're dealing with, and you, as Dad will tell you, you do everything in your power to be able to learn as much about the fight that is underway as you can. I want to make it clear, when the president when I decided not to run for president, I had indicated in the Rose Garden that when I made that announcement that had I been president, one of the things I would devote my administration to was a Manhattan Project, a moonshot, a lot of moonshots on cancer. But the truth of the matter is, I believe from my exposure over 2 years of my son fighting glioblastoma, the brain, stage 4, that I know I became acquainted enough with the brilliant minds around this table and others to realize that we're on the cusp, you're on the cusp of some phenomenal breakthroughs. In my terms, not your medical terms, we are at an inflection point in the fight against cancer. If you think about, as I say to the media, this is everyone in this room from Penn understands this. I used to have a good friend named Bob Gold. I'd say, Bob, do you understand me? He said, Joe, I not only understand you, I overstand you. Everyone in the profession overstands what I'm saying. But the fact is that up until, in my view, and I'm no expert here, although I've tried my best to learn as much as I can the last 2 years, it really wasn't until 4 to 8 years ago we began to challenge the typical way in which we treated cancer. Every one of you who have had a family member over the last 10 years of cancer, you learn the same thing. There's a scalpel to remove a tumor if it can be removed. There's chemotherapy, and there's radiation. And it's a pretty brutal process. A lot of these docs and docs around the world, I've now met with over 200 leading oncologists in the world, and clinicians. Part of what moved these men and women, presumptuous me to say, was a more humane treatment to deal with this disease. And God willing, in a decade, we're going to look back and say, how did we treat cancer in the 50s the way we treated it? There was a lot of talk 20, 30, 40 years ago to immunotherapy. There was a lot of talk about the dream of the possibility of genomics and the rest, but it was not on the horizon. And so I had a long talk with the president, told him what my intention was, and I'm so flattered that my fellow congressmen are here. Shaka Fatah, an Irish guy who's a Democrat, who's a Republican, should be a Democrat. I kid him all the time, but he's a great friend. Patrick is a great friend of mine, and others that are here. That we really are committed as a government, as a Congress, It's not because of me, but if you notice, the only thing that got a spontaneous standing ovation in the president's speech was the announcement of us taking a very, very targeted approach. And I want to make it clear, as I'm going to yield to Dr. Collins in a minute, this is not an NIH program per se. This is not a federal initiative per se. This is using all the assets and capacities of the federal government. There's an executive order the president is going to be announcing shortly that is going to put me in charge of it. It tasks every major agency in the federal government to be at my disposal in a literal sense and take from them the best they have in the areas they have, kind of like I did, gentlemen, in the Recovery Act, and put together a team and have an executive director where we become, we already are, I believe, through NIH, value added and are part of the process, where we break down where it is real, some of it's imagined, where there are bureaucratic barriers, where we can accommodate and speed up rationally and safely additional research and development. But one of the things, Madam President, I've found is there's an awful lot of stovepipes for this operation. I hope my medical colleague, my medical friends here will not be offended, but I used to have Congressman Meehan, I used to have a grandfather named Ambrose Finnegan from Scranton, Pennsylvania, a Santa Clara graduate, a very bright guy, and he used to say to me, Joey, there are three kinds of politics in America. There's church politics, as in Roman Catholic. There is union politics, as in labor. And there's politics. And he said they're difficult in that order. Well, I hope you're not offended, but there are four kinds of politics in America. There's cancer politics. There is church politics, union politics, and politics. They're difficult in that order. And it's not even intentional. It's not intentional. There's a desire of everyone here to be collaborative. There's a desire to be collaborative, and you are already. You're working with MD Anderson, other organizations, major cancer research hospitals. But as I go around the country, and I have now met with scores and scores of folks, we have the Quilt Coalition, the Parker Institute, which you're part of here, the Oncology Research Informational Exchange Network, the American Society of Clinical Oncology, the GBM Agile Project on GBMs, which includes 170 international oncologists and researchers. There's the Biotech Industry Organizational, they're Friends of Cancer Research, et cetera. And they all have particular expertise, none more than here at the university. What I'm finding is that there still are stovepipes that exist. More existed in the past, but today they still exist. Some of them are of, and I'll be coming to my colleagues and who are really the leaders in the House and Senate on this in both parties. But for example, basic questions like, when you do the genomic testing, who owns that genome? Me or you who do the test? Well, right now, that's not so clear. Most of you don't want the individual to own it. You all want to own it. There are a lot of practical questions. But by and large, what's exciting is I've noticed just in the last 2 years, the cross-pollination that's going on now that didn't exist before. Absolutely. All of these doctors are in their own right exceptional. I just happen to know Dr. June and his reputation more than most. I mean it. He's internationally known, as others of you are. When people think of Dr. June, they think of immunotherapies. But he also is working very closely on genomics, and there's a lot of collaboration going on now in virology, a whole range of things that 5, 7, 8 years ago we almost didn't mix. There's even movement, and I don't know enough to know how much pay dirt there may be there, but the neurosurgeon who did two of my craniotomies, that's where they had to go in twice to find a brain. Back 25 years ago, the head of the Department of Neurosurgery, University of Virginia, is talking about high-powered ultrasound.
Yeah.
There's all kinds of things that are occurring in the field that up until recently, other disciplines would say, what the hell are you going to invest in that? But I find a much more collaborative atmosphere. And so what my role will be, and this, that old joke goes, may be above my pay grade. This is one of the most difficult and complex undertakings I have taken on in my career of some time. I became, quote, an expert on strategic doctrine, nuclear weapons, on the issue relating to arms control. What I was able to do then, back as a young man, I literally sat down with our laboratories, and they literally sat with me over a 6-month period and taught me how to make a nuclear weapon. So I'm not joking. So I fully understood. So I learned what the PSI of an SS-18 Soviet silo was. So I knew when I spoke, I knew as much or more than anybody with whom I was speaking. This is beyond my capacity to do that. No, I'm not being solicitous. I mean it. But hopefully I can be informed enough across the wide spectrum that I can be, and my colleagues, we can do two things. We can have the federal government and the American people step up in their contributions, financial contributions to the fight and investment in these technologies, as well as coordinate and collaborate all the agencies within the federal government led by Dr. Collins, so that we are partners, not impediments. We are partners with the private sector. Lastly, Madam President, there are some very generous people out there. I have now met with, I didn't know there were so many billionaires in America. Literally, I met with some extremely, Parker, who is very much involved with your efforts here. There are some really, really fine people, including Governor Huntsman and others, who have made enormous investments in charitable investments and philanthropy to deal with this subject. And so my hope is that I can be a catalyst to overstate it, oversimplify it, to sort of get everybody on the same page. And the goal is, whatever breakthroughs we can make in 10 years, my goal is to make sure we can do it in 5 years. My goal is that we find absolute cures, but for some cancers, we get to the point where we can manage them, they become chronic diseases. For others, so I don't want the press or our folks out there saying Biden is being naive and saying we're about to cure all cancer and we're going to do it tomorrow. But we can fundamentally change the life circumstances of millions of people around the world. Worldwide, this is the biggest killer. And if the United States is nothing else, I was once asked by President Xi, and I will stop with this, who I have a long relationship with, the president of China. We were in Chengdu, and we were having a private dinner, and he asked me, he said, "Can I define America?" It's a true story. And I said, "Yes, I can, Mr. President, in one word: possibilities." That's the uniqueness of this country. Limitless possibilities. And the intellectual capacity and dedication we have just around this table. But throughout the nation, throughout the world, this is a place where the United States can make a contribution that exceeds almost anything we could and will have done so far to humanity. And I was joking with my colleagues a moment ago when I was saying to Dr. Dang, we were talking about what's going on. I said, if my mother were here, she'd look at you and look at you, doctor, and say, "You're doing God's work." Because that's what this is about. We can do so much. So with that, what I'd like to do is yield for a moment to Dr. Collins, and then I'd like you to open up and I'd like you to educate me. I'd like you to talk about what you think I should most be doing as I put this task force together. And my commitment is not just for the next 12 months. My commitment to do this, and I've been stunned by the response worldwide. I mean, absolutely, you've seen some of it, Doctor. I've been stunned at the overwhelming response of welcoming me to ask me to maybe be a facilitator and convener. I plan on doing this the rest of my life, and so I need your help. With that, why don't I give you, Doctor?
Well, you have heard from someone with a vision that I think we all share. The Vice President, passionate, principled, and delightfully and characteristically unplugged and unscriptable, which I think adds very much to our affection and our delight in being able to be part of your team. The President assigned you the job of mission control and the State of the Union, and we're delighted to then be in that jet propulsion laboratory mode here to try to figure out how we can make this particular moonshot happen, to speed up that discovery rate, and to take that inflection point, which I think we all agree has arrived, and move at an accelerated pace those opportunities into saving lives. So we're on your team. I might ask, before I just say a couple words about some of the science that maybe we want to talk about, Dr. Chi Van Dang, maybe you could quickly identify the people at the table so everybody knows who is here. Yes. I will identify Dr. Douglas Lowy, who's my colleague, the acting director of the National Cancer Institute, who traveled up here with the Vice President and me today, and we're both delighted to be here at Penn, a place that we give a lot of money to, and know that it's all very well spent.
By the way, I should, full disclosure, the reason I picked Penn is because my son went here, my daughter went here, my granddaughter's a senior here, smartest. My nephew is coming here, and my niece is coming here. Other than that, there's no. I want to admit to the press my self-interest.
And you have a son-in-law who's across town. Does that count?
Well, by the way, I have a son-in-law who's one of the leading. I can say this, and is one of the leading surgeons in this country. He does the flaps that put people back together after you guys take out the cancer. And he's over at Jefferson, and I'm proud he's my son-in-law.
Chief, please.
Great. So first, I want to thank you for being here and choosing Penn and Philadelphia as a launching pad for your moonshot. So we're really excited today about that. So on my right is Dr. Adano O'Rourke, who is a neurosurgeon at the best level you can find, and he's participating with Dr. June on some of the therapy for brain cancer. Dr. Angela Michel, who's one of our key breast cancer researcher and a great clinical scientist who works in big teams to really solve big problems. Then at the end, you have Dr. Sunil Singhal, who's we just launched a Center for Precision Surgery, speaking of precision in general. So he's innovating in an area where you can make cancer glow, so you can take it all out during the operative. Dr. Grupp has been a champion for the CAR cell therapy for children, and we have one of the patients in our audience. And
Emily.
Yes, Emily sitting there with her parents. And then you have Dr. Vonderheid, who's one of our top immunology researcher, who's very much into creating vaccines and other things for cancer. And then, of course, you know Dr. June, who doesn't need any introduction.
Great, thank you. Well, the Vice President, in announcing this intention, has focused, based on these many meetings he's had with leading oncologists, on several areas of exceptional opportunity, and I suspect those are kinds of things we might want to talk about. One of them is genomics, and of course, having had the privilege of leading the Human Genome Project, I can't help but mention that one. But it is certainly the case, since cancer is a disease of the genome, and we now have the technologies to be able to read out all the reasons that a good cell goes bad and causes a malignancy. This is an advantage that we've arrived at fairly recently, to be able to do that at scale with the ability to sequence a complete genome for $1,000. But immunotherapy, if you ask me, is in fact maybe the area that shows the most remarkable promise at the present time, and much credit to people at this table and at this institution as well as others. Immunotherapy got started in 1891 by William Coley, who tried infecting patients with cancer with various bacterial toxins and noticed that some of them responded. But he had no idea why, and people considered that was sort of a quack kind of thing to do, and it faded into the mists of time. Our own Steve Rosenberg at the National Cancer Institute labored away at this for several decades, usually failing, but occasionally succeeding, and not quite sure why his melanoma treatments sometimes worked. But I think the full flowering of this is really just in the last few years, with people who've come up with these checkpoint inhibitors that have received the Lasker Award, and with Carl June and his colleagues' work on the CAR therapy, basically taking immune cells and educating them about how to find those cancers. I kind of like that metaphor that we all have immune cells, they're all around there, they're natural born, they're looking for things that they need to react to, but sometimes they miss stuff. And sometimes they need some education. And Carl and his gang have figured out how to take them to college. And the results of that, Emily being an example, are really dramatic. Maybe now what's one of the things we might talk about is how do we now move that from the kinds of cancer where it's working really well, leukemia, lymphoma, into the solid tumors, into pancreatic cancer, glioblastoma, prostate cancer, breast cancer. Maybe they need to go to graduate school. And how do we figure out how to go to that next step? Because every cancer is characterized by mutation. That means it has abnormal proteins. That means the immune system ought to be able to find those if we can figure out how to make them more visible. That is, to me, a truly amazing moment where we've gone from what was kind of a even controversial area where some people said you're wasting your time with this immune therapy for cancer to now being the breakthrough of the year just 2 years ago and getting better all the time. I think the third area that you have pointed to, and rightly so, is sharing data. There's a lot of data out there, but it is not accessible to people who might be able to learn from it. And I can tell you from NIH's perspective, this is one of our highest priorities. We are absolutely determined that anybody who's getting dollars from the NIH or the NCI to carry out these kinds of researches, they need to make that data accessible. There are resistances there. There's a tradition maybe of holding your data a little too close. We need to break that down. People say, how are you going to do that? It's like herding cats. Well, maybe it's hard to herd cats, but you can move their food. And that's something we at NIH, we got the ability to do that. We got a lot of food, thanks to the Congress and the administration, about $32 billion worth of food. So we're going to use it wisely in that regard. So putting those things together, genomics, immunotherapy, and wider data access for all the clinical trials that we need to do, and we need to expand that space dramatically as well. I think we are at that inflection point that you have very much articulated just now, and that we could, with your help, with your leadership, with your visibility, your credibility, we could turn this into a historic moment. And I want to say, from me as the NIH director, we are right there with you. We're on your team. We want to see this happen. Now we give it back to you, and you can ask these folks questions.
What I'd like to do is just, why don't you, if you would, whomever would like to start, go off of what Dr. Collins just said in terms of this immunotherapy now, moving to different cancers.
So maybe I'll ask Dr. O'Rourke to tell us a little bit about the challenges that he faces as a brain surgeon.
And speak up.
And then to segue into what immunotherapy could
I'd be
do
happy
answer
to.
the
I'd
question.
first like to say I'm sorry for your personal loss. It's terrible to have had to bear witness to that disease. So I don't really have to tell you how important getting a cure for glioblastoma is. The second thing is I'm glad you chose Penn, obviously, but we do have a very collaborative environment here. Dr. Dang, Dr. June, others around the table. I think it's unique, and I think it places us in a very good position. So let me tell you why I think, why I'm particularly excited about glioblastoma for the first time over the last 12 months or so. The holy grail, if you will, is that the central nervous system in the brain was what they call immune privileged, and no immune cells got into the brain. And so we've recently found that that's not the case. I'll get into that briefly. But we're at a unique opportunity, not just for glioblastoma, but to really identify what the relationship is between the immune system and the nervous system. I mean, it's a huge question, and it's actually beyond glioblastoma into a lot of other neurological diseases. So one of the basic research elements of our project with Dr. June on glioblastoma is to look at how those two systems relate and interact. I think it's a huge question. Now with glioblastoma, immunotherapy has become very much a hot topic. And at Penn, what we're doing that's unique is the CAR T approach. There's a particular mutation in glioblastoma that's only expressed, unfortunately, in about 1/3 of the patients. And we've been able to take a patient's T cells out of the body and engineer them to identify and recognize that mutation, and then literally give them back the cells like a pint of blood at the bedside without any side effects. And we've treated a number of patients now. And the most fascinating and really exciting moment for me a couple of months ago was when we saw some of the early results where we were able to identify in the brain specifically activated cells that we had infused into a patient. Not only that, we saw that the cells were active in the tumor cells which expressed that mutation, eliminated the mutation, and persisted in the body without giving side effects. And so I don't want to oversell it or overstate it. I think your remarks are very cogent. But we have a template on which to build that.
Can I ask you a question, Doctor? And I think I know the answer, but I think it's worth other people hearing it. One of the things that surprised me in working with some of your colleagues at MD Anderson, some of your colleagues at the University of San Francisco, and at Duke, was that, as you pointed out, it works in 1/3 of the patients. It kind of goes back to the thing that Dr. Collins said back in 91. We didn't know why it worked, when it worked, and so could you speak to that a little bit? Because as I understand it, and I'm way above my pay grade, as I said, way above my pay grade, but as I understand it, different cancers, particularly glioblastoma, because of the way it has almost tentacles, the way it functions and grows. There are multiple cancer genes within a single cancer cell. And so it works for some. You can have a targeted response. The criticism I get, not criticism, the comments I get from the genomists and others is that you have to fire so many missiles at the cancer cell that you can find specific drugs and T cells that you can target for certain of the elements of the cell, but not all. So talk to me and my colleagues a little bit about that.
I think we're at the early stages. Because
the Vice President talking with doctors and researchers about curing cancer. We're going to leave it here for today's update on the Republican retreat in Baltimore, where